Welcome to my CCNA Connecting Networks. This is the fourth group of videos in the fourth set for your CCNA. This happens to be the last chapter in Connecting Networks, Chapter 9, Networking Troubleshooting, or Troubleshooting the Network. This chapter focuses on troubleshooting. We're going to talk about the troubleshooting with a systematic approach, we're going to talk about troubleshooting the network, and we're going to end with a summary. So, when you troubleshoot with a systematic approach. We're going to talk about how to document, how to describe general troubleshooting process developments, how to describe the troubleshooting tools used to gather and analyze symptoms of network issues, determine symptoms and causes, and we're going to look at how to troubleshoot a network using the layered model approach. Documenting the network. Documenting is such an important thing that most organizations fail to realize how much time can be saved by proper documentation. The crappy part with that is most organizations don't spend the time or energy in having a complete and accurate and current set of network documentation. So the documentation can include things like the physical and logical topology, baseline performance levels, config files, network configuration files, and in-system configuration files. Those are really important that organizations don't normally document or record. The network topology diagrams, the physical topology could be like device types, model and manufacturer, OS, cable types, cable identifiers, cable specifications, cabling endpoints, location of those endpoints, and the physical components. On the logical side, it could be things like addresses used, address and prefix length. If we're documenting the entire network, maybe what address ranges go to what portion of the network. What do they identify? Also, what interfaces are we connecting through? If we're dealing with frame relay, do we have an appropriate DLCI? Is that documented? What routing protocols are there? Are there any static routes? Are we using a non-traditional data link layer protocol? Are we using Ethernet? Are we using frame relay? Are we using MPLS? I don't know why I said frame relay because that's not a layer 2 technology, but I mean, are we using ATM? I mean, understanding of how the network is laid out at the logical portion is extremely important because that's one area that often can quickly change that we must make sure is documented. Baseline. Questions that a network baseline should answer. How does the network perform during normal, average hours? Can the network meet the identifiable policies? What part of the network is most often used? What traffic is most often used? Are there any errors that are occurring? Are there any thresholds that we need to be aware of? So how do we establish a baseline? Identify the type of data being collected, normally through some type of baseline program. Here we're looking at the Cisco Wide Area Application Services for baseline collection. Identify the devices and ports. Determine the baseline duration. Are we looking at a baseline for an hour, 2 hours, 24 hours? What? So how do we measure data? And I don't agree with this, but this is how they present this. Commands that are useful for the documentation portion, separate from measuring data. Things like, keep in mind, you're doing this from the network device. Ping, telnet, the different show interface commands, show route commands, and the neighbor details. I don't know what they have to do with measuring data, but these are the ones that we look at for documentation purposes. General troubleshooting steps. Gather symptoms. Isolate the problem. Implement corrective actions. Was the issue fixed? If yes, document. If no, repeat step 1. Though this is a generic troubleshooting process, this is not by far the most complete. Stage 1 has so many subportions that they should be broken down even better. Stage 1, ask questions, gather symptoms, see what was going on. That way we can see what's changed. That way that may help us isolate the problem. But you have to ask questions. Symptoms. For gathering symptoms, ping, traceroute, telnet, the different show commands. Questions, again, at this process. Ask questions that are pertinent to the problem. What does not work? When did it stop working? Are the things that worked and the things that are not working related? Has things that does not work ever worked? That's a dumb question, but honestly, I've actually seen that that's been very useful because I took care of one client where they were complaining that a feature didn't work, but it turns out that feature had never worked before, and they just continuously complained about it. So it wasn't like a new issue, it was an issue that was always there. Can you reproduce the problem? Can you make sure that you understand the end user's problem? And once you fixed it, did you verify with the end user that it was fixed? If we're looking at the layered model, physical is going to be wiring. I don't know why they have a hub there. I think that's more of an issue or a placeholder that they never fixed. Data link is going to be more switching. Do you have a layer 2 or a layer 3 switch? The upper layers can be, again, the upper layer models, layer 3, 4, and 5, that could be a multi-layer switch, so a layer 3 switch. Could be a router or other layer 3 device, sometimes a firewall, though it's really funny because the firewall typically is also a router or a router with firewall capabilities. Alright, granted, some people are going to get angry when I say that. An ASA is a firewall, but it also has routing capabilities, so wouldn't it also be a router? So I mean, just food for thought. And then the upper layers 5, 6, and 7, that's going to be end user. Alright, so troubleshooting methodology. There are typically 3 defined by Cisco. Bottom up, top down, divide and conquer. Bottom up goes layers 1 through 7. Top down, layers 7 through 1. Divide and conquer are always a fun one because that's where you start dividing and you start crossing out different areas. So the troubleshooting methodologies are systematic. Normally you want to do them in such a way where you're not going in a giant circle. One troubleshooting approach is based on the educated guess by the network administrator, based off the symptoms. Another approach involves comparing a working and non-working situation and spotting the differences, assuming there are differences that you can spot. A third one is swapping the problematic device with a known working device, but again, that's not always realistic. For example, I've had one situation where we had a core switch going out and we did not have a spare core switch. It happened to be a Nexus 7K and they're kind of expensive. So we only had 2 in the network. And when one started giving us trouble, we didn't have a spare. But I mean, if it's a lower level equipment like a distribution or access layer, then not that big of an issue because again, that's going to be cheaper and you may have more of those laying around. Guidelines for selecting a troubleshooting methodology. They want to say things like top down is more limited, and if you already have the turning the skill with the product, it's a little bit more complex. Honestly, all of this goes back to the individual doing it and their experience. As you get experienced, you're going to figure out which one works best for you, and that's what you're going with. Network troubleshooting. Software troubleshooting tools like knowledge-based tools, baseline tools, the host-based protocol analyzers, the Cisco IOS EPC. We also have hardware tools, digital multimeters, cable testers, cable analyzers, network analysis modules. This kind of depends on what we're looking for. Let's go back to a previous level when we talked about Syslogs. Here we have our 8 levels of severity. emergencies, alerts, critical error, warning, notification, informational, and debugging. And they're the appropriate descriptions and definitions. Big thing here is these don't go away. You're expected to know these by heart. You will have, as you progress onto higher level material, CCNP route, for example, CCNP switch, troubleshoot, or T-shoot, you're expected to know these. So I understand that this was brought down to the CCNA level, but this is also still very critical. If we're looking at the physical layer troubleshooting, performance lower than the baseline, connectivity issues, link lights that are going up and down. If we're talking layer 2, maybe frame issues, STP failures, again, traffic that's kind of going weird ways. Also, STP is not set up correctly. You could end up having switching loops, but I mean you could look at the switches to kind of see link lights to see if that's happening. Errors at layer 3, general networking issues, connectivity issues, topology, database updating tables. Topology, database, and updating tables may not be occurring correctly. The flow of traffic may not be happening. You may be getting really crappy performance, but you can always do that with the appropriate show commands. Layer 4, ACLs. This is always a big one with ACLs here. Typically, misconfiguration of ACLs happen at layer 4. Also with layer 4, we're looking at things like DNS, SNMTP, tunneling and encryption protocols. Also looking at NAT. Layers 5 through 7, that's going to be more application based. So it's just kind of, again, based off application. If we're looking at the OSI model versus the TCP IP model, here they are side by side. Again, very similar, except it's a 7-layer versus a 4-layer, but pretty much identical layers. They may be combined layers, but I mean it's the same general concepts. End-to-end troubleshooting, this is always really fun. Check physical connection, check duplex. But okay, realistically, if the device is working today, but later in the afternoon it stopped working, it's highly unlikely that the duplex changed. Maybe the cable died, maybe the port died. So, I mean, some of this you have to take with a grain of salt. Check for duplex, check the data link layer, make sure that you're getting an address. If you're not getting an address, make sure that you can connect to the switch. If you can't connect with the switch, make sure that your link is still valid. Do things like verify gateway. Can you ping the gateway? If you can ping your gateway, look at the next layer. Look at the transport layer. Make sure it's functioning properly. Can you telnet? Can you access the appropriate other protocols that are there? Verify there's no ACLs blocking traffic or shaping traffic. Are DNS settings correct? Are you pinging Google? Are you pinging its IP address? Are you pinging its domain name? Things like that. Use ping and traceroute from a workstation to kind of see the flow of traffic. Verify the physical layer. You can always do show commands, show interface. Here we're doing check for a duplex. Verify things like show ARP, show MAC address table. Look at layer 3 addresses. I don't know why we said ARP, because ARP's not really a layer 3 address. It's more of a layer 2. But I mean, double check things like, do you have an IPv4 address? Do you have an IPv6 address? Can you ping the gateway? Verify the gateway. Are you sure that you're taking the correct path between A and B? Verify transport layers, telnet. Again, review ACLs. Verify DNS. And again, with this, experience will define how you troubleshoot. And that's the end of our CCNA material. We have a lot of labs for troubleshooting, so if you have any questions, please let me know.